Okay, now we're going to look at the root test. So although the root test is not on the AP exam specifically, it is a nice little test that we can use anytime we have something, a quantity raised to the nth power. So if it's raised to the nth power, what we can do is take the nth root of it and then take the limit of that. If the nth root, if that limit is greater than 1, or if it's infinity, just as in the ratio test, then that gives us divergence. If it's less than 1, then that gives us convergence. And once again, if it's 1, it's inconclusive. So the rules are the same. You just have to do a different step, and that's take the nth root of the series. So from here, we have e to the 2n over n to the n. Once again, we want to look at the nth term test. And the nth term test tells us the limit as n approaches infinity of this would be 0, because n to the n grows faster than an exponential. So we can rewrite this as e squared over n raised to the nth power. So what I want to do is I want to take the limit as n approaches infinity of the nth root of e to the 2n, e squared over n, raised to the nth power. And of course, the nth root of that is simply the limit as n approaches infinity of e squared over n. And we know that that limit is 0. And so since the limit is less than 1, this converges. Okay, once again, we want to do the same thing. We want to take the limit as n approaches infinity of the nth root of negative 3 over 2n plus 1. And I'm going to raise all of that to the cube root and then raise it to the nth root, because that's sort of the same thing. So when I take the nth root of that, I get the limit as n approaches infinity of negative 3n cubed over 2n plus 1 cubed. So essentially what that will give me is negative 27 over 8 when I'm cubing just the numbers, and n cubed over, and the reason I ignore the 1, because as we go towards infinity, that 1 becomes negligible, so I'm ignoring it. So I get negative 27 over 8. Now our rule is, which is greater than 1, because we're taking the absolute value of this. And since this absolute value is greater than 1, we're going to say this diverges. And really, this failed the nth term test, because we have negative 3 over 2 as n goes towards infinity. So it actually failed the nth term test. I just didn't pay attention to that. So this diverges because it's greater than 1. Okay, once again, so I'm going to take the nth root of this. When I take the nth root of this, I just end up with the natural log, the limit as n approaches infinity of natural log of n over n, because I've taken the nth root of that. That got rid of that. And of course, that is 0. Because it's 0, it's going to converge because it's less than 1. Same thing here. Actually, I think this is going to fail the nth term test, because as this goes towards infinity, it ends up looking like 2 to the nth. And 2 to the nth, of course, will diverge by geometric, because it's greater than 1, but the nth term test fell, because this will go on forever. This is infinity, and it's not 0. If you don't like that, then we can just do the limit as n approaches infinity. Taking the nth root, we get 2n over n plus 1, and that limit is 2. So both ways show us that this diverges because we got something greater than 1. And that is the root test, and that is all of the tests that we will learn for this unit. So you have successfully learned 10 tests. So do the happy dance. I'm doing a happy dance with you. Okay? All righty. Study for your quiz tomorrow, and I will see you tomorrow.